kind of started to do. We kind of ran out of time. If we would have had more time, I would have liked to have explored this a little bit more. But most people got to this stage right here. There was a second triangle that we could have made, but we're trying to identify patterns here. Something that we noticed here. This triangle that we created has a side of 3 and a side of 4, and then we create a square off of each of those sides. And then we laid a second piece of paper over here to create a square off of this side here. And one thing I told you to look for was patterns, particularly with these smaller squares related to that larger square. Did anyone notice any patterns with the area of those smaller squares to the larger square? Scout? Say that guess again, louder.
Add the two small ones, add it up on equal the bigger one.
So if you add up the area of this one, you add up the area of this one, it'll equal the area of that one? Are you just guessing, or does it look like that might be true?
It looks like that's true.
It looks. What would the area of this one be? 9. So I'm just going to put my 9 right there. And what's the area of this one? 16. And then the area of my larger one? Is 9 plus 16, 25?
Yes.
So it seems to work for that one. Seems to work for that one. And that's actually what I wanted you to take away from that yesterday. Yesterday, had we continued with that activity, you would have seen that every right angle, every right triangle, the length of the height and the length of the base, if you square both of those, it'll equal the length of your hypotenuse. Let's look at a couple more examples on this one. You do not have to draw this.
So what's the length of the diagonal of the diagonal line 5?
Yes. Yeah. So let's look at a couple more examples. So if I say that the height of that right triangle is 5, and the width of that is 12, and I'm missing this side right here. That side I may not know. I can find that by using what's called the Pythagorean Theorem. We said earlier that if I take whatever square this is and whatever square this is, and I add those together, it's going to tell me what the size of that square is right there. So what I'm going to do is find the area of this square. 5 times 5 gives me 25. So this square is 25. 12 times 12 gives me 144. So then what's the area of my larger square going to be? Natalia? All right, so 169. How can that number help us to find the length of that missing side, though? There is an operation that we've learned how to use that will help to find our answer. Emily? The square root, yes. When I find the square root of 169, I get 13. So that tells me that the length of that side is 13, because if I multiply 13 times 13, it gives me our square. Let's try another one. Let's try, these are obviously not drawn to scale. If I have 9 and 40, obviously they're not drawn correctly. What would the length be of that missing side? We'll call it C. Brian? How'd you get that? So you got that answer right there, and then you did the square root of 1681, and that gave you 41. That is correct. Very good. Yes, Scott?
Can you the length of the long line and the other one, would you subtract the smaller one?
We'll be doing that exact thing in about 5 minutes. Here is the Pythagorean theorem. Let me put all of this together. One of the nice things about algebra is that we don't have to just look at examples. We can look at variables that will represent any time we have a right triangle. I always make my up and down my A. That's the height of my triangle. And I make the down my B, like base of my triangle. And C is always the hypotenuse. What the Pythagorean theorem says is that whenever I have my A squared, no matter what the square of this is, and I have the B squared, no matter what the square of this is, if I add those together, it'll always equal the square of my C. I don't always know what those numbers are, but if I have two of them, I can always find the third. Because they're related in the equation, A squared plus B squared equals our C squared. We take our first side, find the square, and our second side and find the square, and that'll give us the square of our third side. So let's look at a little bit more organized notes. All right, today we are looking at the Pythagorean theorem. What the Pythagorean theorem says is that A squared plus B squared equals our C squared. That's what it is, just algebraically. If you are given a triangle, and none of our triangles today are going to be drawn to scale, so doing what I can to make even straight lines. You can only use the Pythagorean theorem if it is a right triangle. That's the first thing that you'll need to know. If we say that the height of this triangle is 9, and the base of this triangle is 10, and we're looking for the hypotenuse. The hypotenuse is the diagonal. It's the longest side across from the 90 degrees. In order to do that, we're going to take our A squared, which is our 9, add it to our B squared, which is 10, and that'll equal our C squared, which is our unknown. Most people just enter it straight into the calculator. There's your squared button is right there next to the 7. Plus 10 squared gives us 181. Honestly, you guys probably don't need a calculator. 9 times 9 is 81. 100 squared is 10 squared is 100. Adding those together is a pretty simple process. So what you'll find there is that 181 equals C squared. Now this is the part that we're trying to solve. Our answer is not 181. I guarantee there's about 3 people in this room who are going to put 181 as their answer. It is not. 181 is the area of that side, not the length of that side. So if the area is 181, what we have to do to undo that square is to find the square root of both sides. So in my calculator, I'm going to do the square root. That's second x squared gives me the square root of 181, which is C equals 13.45, or 45 hundredths. Let's try another one. Let's say that the height of this triangle is 11 and the width or the base of it is 60. Find the missing side. Find the length of the missing side. Anybody think they got it? Slam and Sammy, what'd you get there?
61.
And how'd you do that? Walk us through it, because there's some people that kind of give me that look like maybe they don't know how to do it. Walk us through how you did that.
I did 11 squared
Mm-hmm.
plus 60 squared. And then equals 60 squared.
Yep.
And then I did, there are 11 squared plus 60 squared equals 3,721.
Okay.
And I did the, square root of 3,721.
And it was 61. So in our problem, our C there is 61. So it's 61. Excellent. Very good. Nice job, Sammy. You're not always going to have pictures. Sometimes they'll give you just the letters. And honestly, for me, it's a little bit nicer to just have the letters instead of having to deal with the pictures, because then you don't have to guess which one's my A, which one's my B. Solve for that missing side. As a side note, your A and your B can always be switched. They do not have to be the same. Your C is always your hypotenuse. It is always that longest side. It is always the diagonal. It is always the one across from the right angle. Hypotenuse is always C, the longest side. Alright, you bet me they got it. Aiden, what'd you get?
1.133.
Excellent. And how'd you do that, Aiden?
18 squared.
Yeah.
Plus 100 squared. And then, and that equals 1,165, and then use 1,165 squared, and then that equals 34.
Did you say 11,165 squared, or the square root of 11? Yeah, there you go. Yeah. So you find the square root of both sides. So you do the square root of that answer, and that gives you that 34. Excellent. You ready to increase the difficulty a little?
Yeah.
I know you are. I know you are. We'll start with baby steps here.
You can still roll it.
So now we're changing it on you a little bit. I know my A and I know my C, but I'm missing the B. Try that. All right. What? Yeah. You called me. Yeah. All right. So I may not be able to convince my wife to get a 70-inch TV, 75-inch TV. I will not give up, though. I think we don't have to eat. We can watch Food Network. We'll be fine. Scout, what'd you get? 63. Now, tell us how you did that, because now I'm missing the B. How did you get 63 there?
I did 65 squared minus 16 squared.
Hold on. You did 60.
That's right.
Well, let me do this. B squared equals a C squared. Now, what did you do?
I did 65 squared minus 16 squared.
Ah, do you see what he did?
No.
So here's what he did. He's got A squared plus B. Why am I writing the variables there? I'm just going to write the actual numbers that he's using. So his A is 16, so he's got 16 squared plus the B squareds are unknown. C squared is our 65. What's nice about the algebra is it's the language of math. We can all kind of like understand what he's describing, even though he did this in his calculator a different way. This is what he was doing. So in order to get this, he actually subtracted 16 squared from both sides. So then when he solved this, it's B squared is going to equal 65 squared minus 16 squared. You see how he did that?
Yeah.
So the goal here was to get B squared by itself, subtract 65 squared, subtract 16 squared. So when you did that, what'd you get? You got, what'd you get?
63. That's what I got. Well, never mind. I got 3,969.
Yeah, okay. That makes sense. All right, so 3969. And then you had to find the square root of that, right? Very good. That's what I got also. Let's do another one like that that has a missing interior side. So if you kind of got lost on that last one, I'm going to walk you through it right here. Your A is 5, so it'll be 5 squared. Your B is unknown, so it'll be B squared. Equals your C, which you do know, which is 7 squared. So now what I'm going to do is, before I actually do the squared part, I want to get this B by itself. So before I do 25, I'm just going to subtract my 5 squared from both sides. So then here will be B squared equals 7 squared minus 5 squared. That's what I'm going to put into my calculator. So in my calculator, I'll do 7 squared minus 5 squared. Gives me 24. So B squared equals 24. And now I have to find the square root of 24, which gives me 4.89, which is really close to 4.9. Try that one. Just a second. You said, what if there's a negative involved? What do you mean by that?
Like you're trying to figure out what equals, but it is a negative, but you have to add them because if you subtract it, it'd be more.
You're bringing up a really good point. What do our letters represent? The length of the sides, right? Can our length ever be negative? No. So whenever we're dealing with the Pythagorean Theorem, our numbers shouldn't be negative there. So in this one, who has an answer that they'd like to share? Haley? I'm listening. Yeah? Good. I would have done that the exact same way. We had to get A by itself here, so we subtract 15 squared from both sides. So 17 squared minus 15 squared gave you 64. Square root of that is 8. That is perfect.